What'd I say?
It's the clone of the clone.
Yeah, this is gonna take forever. Hello, welcome to the Hackaday podcast. I'm Tom Nardi.
And I'm Al Williams.
This is episode 344, Bored with Lasers, Op-Amp Torture, and Farewell Supercon 9. We are not joined by Elliot Williams this episode. I would say that the excitement of Supercon was too much for him, but he actually had another engagement, so we'll have to press on without him. But Supercon is in the rearview mirror, and it was, I think in a word, fantastic, right? We always have a really good time, and this was no exception to that. We're going to have a little bit more detailed kind of freewheeling about our thoughts at Supercon at the end of the episode, but just to start things off, I did want to say, thanks to you, the readers and / listeners. We couldn't do it without you, and of course the sponsors for Supercon. We had Supply Frame and DigiKey as always. We're also joined this year by Framework and iFixit, Expressive, Arduino, No Starch Press, Crowd Supply. We actually made a bunch of new friends this year, and we couldn't pull it off without you. And thanks to everyone who made Supercon the awesome event that it is.
Yeah, it was a great time. Great time.
We also have, by the time you're listening to this, one weekend left to enter the component abuse challenge. So if you've ever wanted to take out your frustrations on any electronic components, this is your last opportunity. It ends on Tuesday, November 11th in the morning. We have just short of 70 submissions right now. There's some pretty cool stuff on there. We've written up a lot of them, and it's always really cool to see what weird constraints brings out of the community. This one was really fun, where you're basically saying, take something that does A and make it do X. And the community has really come out in rare form for this one, so that's always cool to see.
This is a journey into sound.
What's that sound?
What's that sound?
Previously on the Hackaday podcast, it was a Guess That Sound episode, and I think it is protocol to play said sound again now.
Yeah, let me listen. Yeah, let me listen to it. Well, so far I'm thinking about it being a film projector, but let's see if I still believe that at the end. No, it's stamping or cutting something. Oh boy, and now it's like Boards of Canada music or something. But it sounds like it's 3 different segments of something. It's like something being wound and something being stamped or something, and then music. So, I'd say it's some kind of bizarro musical instrument being prepared and played, but I don't know that.
Well, that is technically accurate. At Supercon, a couple of people had come up and were asking, what the hell was that sound? And it seems like it's 3 totally separate sounds that have just been mashed together, and some people question there's actually one answer. But it is actually a PDP-1 being programmed to play that song, Boards of Canada's Olsen.
Oh, it was Boards of Canada.
Via, you got the song right. It's playing it via the front panel lights. So the lights are like generating a square wave, which is somehow hooked up to a speaker. And what you're hearing in the beginning is the paper tape getting loaded into it, and then there's flicking of switches.
Okay, well, I was not too far off.
I gotta say, when I heard this one, as always, I was clueless as to its source, but I was surprised to see that we had not only a decent amount, it was 32 responses, but almost half of them got it right.
It's clear to me that I'm not good at this and other people are way better at it.
I think, to be fair, I think like Lewin or somebody wrote this up last week. So
I would think the right answer is to differentiate by who got the serial number of the PDP-1 correct.
Right.
So.
It seems like almost all the other answers were Flopatron. But 15 did actually get the PDP-1 correctly, so we have to...
Would you like a random number between 1 and 15?
Yes,
I just pulled one off of a random number generator, and I got number 8.
There you go. Number 8.
I can't see the list, so that's totally fair.
8 is... oh, good. It's a gibberish name. It is 4 star. I guess I'm supposed to say that. The number 4, then ST, number 4R. 4 star.
There you go.
I have no way of knowing if they've won before because I think we're supposed to only do this to one per person. And I also don't know how to send you a T-shirt because Elliot has the keys to that particular mechanism. But I will send your information up the chain, and presumably you will get a shirt, a much coveted Hackaday podcast shirt in the mail in the future at some point.
I'm always saying I don't have a Hackaday podcast T-shirt. Do you?
I don't have one either.
There you go.
I don't know that I've ever gotten. I'm sure I got at least one of them right, but yeah, if there's anyone who doesn't deserve one, it's definitely me because I'm terrible at this.
Well, let's get into the hacks.
Yes.
Yeah.
So my first pick this week, and this is something that I feel like we talk about all the time, but it's an important topic for folks like us. This is this the last PCB you'll ever buy? And the idea here, this is a project that Stephen Hawes has been working on. I don't think in isolation. I think he's been involved with other people on this, but it's essentially a blank PCB that has a grid of vias already built into it. And the idea is that you can then etch it, chemical or laser or even, CNC routing. And as long as you know where these little vias are, and the physical board also has a matching, digital template that you can load into your KiCad or whatever. You could just route your traces to where they are and pop out on the other side, right? And that's kind of, I don't want to say it's the solution necessarily, but it's probably the closest thing we've seen so far to a practical way of doing dual-sided boards at home, right? You already have the challenge of lining up the front and back, but connecting them together has always been the real difficulty, at least for surface mount stuff. If you had through hole, you could always just kind of ride that, but Stephen takes the board and he puts it in a high-powered diode laser this time, cuts out all the traces, and then you can flip it over, do the traces on the other side, and he has the benefit of a pick and place, which most mere mortals don't have at home, but that's neither here nor there. End result is, you can go from digital design to a physical finished board in a little over an hour, and that's pretty good. And again, that's with doing a two-sided design. And I'm not going to say this is a solved problem necessarily, but we've seen a lot of attempts at doing more and more practical home PCB prototypes, and they always kind of have some downside. And at least for this one, the downside is still probably the price. The laser in question is several $1,000s, but not completely outside of the, the hacker realm. When you consider, what's a Prusa XL cost? $2,000 at least, right? With the heads and stuff. It's not. This is not an completely unreasonable amount of money for a hacker to spend on something that if they're going to get use out of it,
or a hackerspace.
Well, right, a hackerspace too. Shit, definitely that. If you can go in on with a couple people for the laser, and obviously the laser has more functions than just making PCBs too. So that's also part of it. So if you have one of these lasers and you get these boards done up, I gotta say this seems pretty close to the best solution I've seen. It is a little weird in that the vias are, they're a fixed element, right? You can't move them; they are where they are. So your layout is going to be a little weird. But if that's the only downside, for a prototype, I think that's still pretty compelling. You wouldn't necessarily. Oh, I guess you could, right? You could still send that off for fabrication. It might not be the layout you would have done, but certainly the schematic would be the same. So that part would just translate over, and you could, even if you had to a redesign of the actual layout, at least you would have tested everything electrically in a prototype.
Yeah, I thought this was super interesting. I've always been kind of a mixed mind. I like to, I've made many PC boards back even when it was harder to do than it is now. And, when I first started writing for Hackaday, I did a post. This was before everybody had really jumped on the overseas bandwagon, although it was starting, right? And I kind of saw the writing on the wall, and I said, listen, just because you can make a PC board, do you really want to? I mean, if that's really your thing, sure. But if you're really just wanting to build something, send it off. It comes back in a week. It's $5, and it's got silkscreen and solder mask, and it's, they're beautiful, right? They look like commercial boards. And man, you'd have thought I had suggested, rounding up babies and making them into hamburger or something. I got really, 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 really angry people in the comments from that. But, I think time has proven me out, right? And don't get me wrong, if that's what you want to do, people like to, whittle woodwork and do all sorts of things. And if that's what you like to do, oh, great, have a good time. But I'm not convinced that there's been many times, especially for a hobby project, where I've been like, oh no, I have to have this board right this instant. And I've got to iterate 10 times today on this board, Usually I can wait the week. And I don't know. But, on the other hand, I have a laser. I wonder if I couldn't try this. And it makes me think, too, I used to get these nice boards from Radio Shack, and they were laid out like a proto board. So if you had something on a proto board, you could just kind of copy it over onto those boards and solder it up, and it would go. And one of the things I used to do was sometimes take an X-Acto knife and kind of surgically change those boards. So I was thinking you could take this one step further, right? What if you had like a bunch of little pads connected with little tiny traces, and you know exactly where those tiny traces are? Then, instead of cutting all the copper off with a laser or a Bridgeport or whatever, you could just go surgically, basically fuse those interconnects. So everywhere you don't want to connect a couple of pads, zap, and just zap one little burn on that. Leave most of the copper there, kind of like when you route mechanically, right? You don't take off copper just for the looks. You isolate everything you want isolated. So that with the vias, that would make a pretty cool prototyping, where 5 seconds in the laser would blow all your little tiny copper traces. I think if I'm going to do a double-sided board with vias, if I'm that desperate that I'm going to do it myself, I don't really mind cutting off a resistor lead and soldering it on both sides, which is what I basically do. But because it's already not going to look great. I mean, and I know, I'm sure there's somebody out there who has a precision technique, and they've got the solder mask, and they've got the silk screening, and but I don't. So my boards, no one's going to look at my boards and go, "Wow, where'd you get these?" They're going to go, "Wow, where'd you get these?" Right? They're not going to. So same words, but same words, but the inflection is everything. So. I mean, it's a great thing, though, and I would, I may even try this at some point. But like I say, I still say 90% of the time, maybe just sending your Gerbers somewhere and having the pros do it. Well, my first hack this week is from Trashtronic, a great name, and it's part of the aforementioned component abuse challenge. It's called Way with a TL074. It's interesting. When I was in high school, one of my favorite teachers, math teacher, I think he's passed on now, but Ken Harder, he used to say, you got to take what you know and use it to find out what you don't know. So, of course, he was talking about algebra, but I've thought about that a lot over my career. This is one of those cases where you want to know what something weighs. How do you do it? Well, obviously you could use a load cell. That would be really smart. Or, they got the spring things and all that. But there's all sorts of things that will react in some way to some pressure on it, and one of them happens to be op amps in a 8-pin dip package. We've seen things like this before, right? There were a couple of microcontrollers back, a couple of decades ago that like their internal clocks would drift with with temperature, so you could kind of calibrate and say, oh, okay, I know it's 30 degrees right now, and because the frequency drifted this much across the, relative to my crystal frequency, I can guess that it's now 35 degrees or whatever. So it's that same sort of thing. The offset voltage really changes apparent with pressure on the package. This is one of those things, and probably almost everything that's going to get submitted to this contest is probably something you would never do in a piece of production hardware.
Right.
Because I'm certain the minute probably you get an op amp from a different lot, it's got a different lead frame because they decided to change vendors, or heaven forbid, if you were to go buy them from somebody else, it probably changes everything, right? So unless it's something you can just calibrate each individual one, I doubt seriously it's that repeatable. But how cool, and I love looking at things like that where you say, oh, I didn't think about this one little effect, could vary with temperature, so therefore I can read temperature, or vary with pressure, so I can read the weight, or I'm sure there's some other things out there. But, what a cool idea. So good job to Trashtronic.
I like that in her write-up, Jenny describes this as something of an op-amp torture device visually, and it certainly looks like something medieval and wrong, right? Like, this is definitely not the way these chips are to be used, and I would imagine with any kind of real weight, you just break the things anyway because you're putting pressure on them. But, it is really the quintessential entry into this contest because, like you said, it's not something you would do in production for many, many, many reasons. But it's hacking in its most raw form. Like I've loved all these entries, frankly. This one is really cool because it has this nice visual of this torture unit, but it's really this is really what it's all about. There was another one I'll link it into the show notes that was using transistors as thermometers, that that kind of stuff, where like to what you were speaking on, where you can external variables have an impact on a measurable facet of the component. So like I said, you probably would never use these in any kind of production thing, but I mean, I think we've all probably been in a situation where we need to throw something together quick with what we've had, right? And I think having some of these and maybe not this one. I mean, this is pretty out there on a limb, but I think there's certainly some of these entries are going to be worth kind of filing away in the mental vault for if you're stuck with only a certain selection of parts, and you just I need to get a rough idea of temperature, and I don't have a temperature sensor, but I have a transistor, that kind of thing. I think could be useful and worth checking out the entries when all is said and done for some unexpected lessons learned. Well, my next one is repurposing dodgy Android TV boxes as Linux boxes, and this is just the latest that we've seen in I think a growing movement of people looking to turn cheap, what some might call e-waste gadgets into useful devices again. This is something that was super common in the pre-Raspberry Pi days, right? And we've talked about that a lot. If you go back to the black and white photo era of Hackaday, there was like a lot of people were taking routers. The WRT54G, right, is like the iconic router that you could turn into a multi-purpose Linux device, and you would see people putting the routers on top of RC cars because at the time that was the cheapest and most practical way to get an internet connected programmable anything stuck to your device. And then of course the Pi came through, and that sort of went away because you had these cheap Linux single board computers that they didn't fight you. They were built to be that. You didn't have to break out the serial adapter and hunt for a debug port to make it happen. You just put an SD card in there and you were running a distro. But of course we all know the Pis have gotten steadily more expensive, and some would argue have kind of moved on to a different target user, right? So now we're starting to see the kind of this rebirth of people saying, well, I don't want to spend $70 for a Raspberry Pi, but here's a set-top box on eBay for $10 that I know at some level runs Linux. Can I make it run my own Linux? And that's kind of what this video is about. It focuses on a specific Android TV box, the X96Q, but I mean, the lessons learned here are broadly the same for a lot of this stuff. In this case, It's a rock chip device, which are not, not exactly burning down the house with performance, but again, these can be had for like $10, and it's hard to complain. It seems with this one in particular, there was no challenge necessarily to get it running a more generic, copy of Armbian. There didn't seem to be any hacks per se. You really just put it on the SD card and it boots directly, right? Which is pretty phenomenal as far as these things are concerned. You don't have to do anything. The one disappointment was once it was running a more pokeable Linux install, it was revealed that its specs were less than what were promised. It was supposed to have 2 gigs of RAM and 16 gigs of flash, and it's both of those are cut in half in reality once you can actually poke the system and see how much memory do you really have. But even for $10, Linux run on anything for $10 for me is pretty impressive. And even this, even with only a gig of RAM and 8 gigabytes of flash, it's enough to have this thing sitting off in the corner and running something, your MQTT server, or do DNS filtering. I mean, it'd be perfect for that. And it, unlike the Pi, it already comes in a nice little box and doesn't look like an exposed circuit board, right? So not only is it cheaper, but it's more, it's ready to use effectively. And with all due respect to the Raspberry Pi, this is what I'm into. I like finding things that are already on the market and would probably end up in the garbage, frankly, if not for running somebody's personal web server. And this is, I think, is really core to our community, and I always keep an eye out for these kind of posts, and I'm glad that Maya picked up on this one.
Yeah, I thought this was cool also, and I look at it a little differently than I think you do, although I still agree. I look at Linux and I think, wow, think about how the whole ecosystem would be different if that didn't happen. Right? If there'd just been all these proprietary operating systems that you had to license, well, you wouldn't have $10 boxes, right? And you wouldn't have, if no offense to anybody that makes proprietary operating systems, I have friends who make proprietary operating systems, but it's really been a game changer to have this kind of universal thing that's in everything, and it's because it's insidiously supposedly free. Now, if you're a company, Linux isn't really free because there's the cost of maintaining and there's the cost of, there's all these hidden costs in it. But it's still something that, when you say, hey, let's make a $10 TV set box, you don't think, oh, I wonder how much Windows is licensable for, right? And I want QNX and I want, So I think that's really neat that, like you say, any particular gadget you pick up, including your cell phone, is likely to have Linux running under it. Now, in the case of the cell phone, there's so much other stuff running on it that it seems like something else, but it really isn't. And it has allowed us to be experts on a lot of things, right? Because if you, let's say you knew VxWorks, okay, that's great, but then the guy that knows QNX knows things you don't, and vice versa. And the lady who uses Windows CE knows something that none of you know. And whereas we all kind of have this common base of Linux knowledge, and it leverages over hundreds and hundreds of platforms. I've been using Unix even before there was a Linux, and I used to always do that. I would look at the reference manuals, and I think, you could write this, but of course I never did it. I always thought this really wouldn't be that hard to write the kernel that did all this, and but somebody did it, and thank you, Linus. Well, my next hack didn't come from one person; it came from a group, as HTX Studio, and it's the reproduced and recovered the first Chinese keyboard-based Mingquai typewriter, and I'm probably not saying that right, but I'm sure someone will correct me. I've always been really interested in this. What is it? This is the Safar-Whorf hypothesis, right? That your language influences your thinking, and I think we see that a lot with how English is versus how other things are. So, Chinese, particularly Mandarin, I think, although I guess all the Chinese variants have that, they have the pictographic language. And so it makes some things really, really easy, and it makes some things really, really hard. I read a long time ago, and I'm assuming it's right, that Japanese computers were way ahead of us on character recognition, because the pictograms are so ornate that if you draw out the pictogram, the computer can easily go, oh, that's boat, right? As opposed to us where you scrawl B-O-A-T and it goes, what? Loot? I don't know. But the problem has always been, how do you generate those on a keyboard? Now, like the Japanese have the two different systems, and so it will, that is a little more conducive. You can press some keys. I think is it kanji I can't ever remember which one's which, but you basically sound it out phonetically, and then the computer can say, oh, here's 5 pictograms that you probably meant one of, and you go, yes, that one. But how would you do that with a typewriter, and especially if just in pictographic language? So Lin Yutang in the 1940s had this bizarro bizarro typewriter where you would overstrike different pieces to form different letters. And there weren't that many of them made. I forget how many they were made. It was a handful, and I think most of them have been lost. And so these people took it upon themselves to take the patent drawings and build a new one. So it's really fascinating. And if you ever used APL, I'm an old guy, so APL, that was how APL was too. Like a comment in APL is a thumbnail, and you did that on a Selectric terminal by typing the little left shepherd's hook, backspace, right shepherd's hook, backspace, the little piece that made the thumbnail. Right? So a thumbnail was like 3 keystrokes in the back, 6 if you count the backspaces. It's sort of like that, where you had to say, okay, here's this and this and this and this. So, how ingenious that is, but it makes you wonder. I mean, just like, say, optical character recognition, English is terrible for that, but typing on a limited number of keys, English is super good for that, and all the other, the Roman languages and things like that. But it makes you wonder what other things don't have representations for that would make things very easy. Think of the Romans with the number system, right? Without positional numbers, math would be insanely difficult, and you would just think, oh, math is bone-crunchingly hard. Well, yeah, because you got the wrong representation. And so that's easy because we know better and we've seen it, but you just have to wonder if aliens show up on the next interstellar comet or something, and they would go, what? You can't figure out how to go faster than the speed of light? Well, you're not looking at it this way. And you go, oh. Right. Or something. I mean, I'm not saying it's that, but whatever. There's probably a half a dozen things that if we just had a slightly different representation of them, it would become trivial, and we just haven't figured that out yet. So that was kind of what interested me on this one, but just the mechanics and just the uniqueness of this, I thought it was a really beautiful build I wanted to highlight.
Well, I mean, to speak on the mechanics a little bit, and this is not really limited to this device, but I think really kind of anything from this era, it is just mind-numbingly complex mechanically, right? And it's so different than the way we do things now, although our own things are extremely complex in their own way, right? Somebody looking at this looks like magic to us, and someone from the 40s, our technology would look like magic to them. It's kind of interesting, but for different reasons, right? I mean, all the linkages and everything that happen in here, whereas today we would just, write lines of code to pull off a similar effect. So it is, yeah, it's really cool. It reminds me almost like an Enigma machine or something, right? Just such an incredible piece of craftsmanship, and it's so far removed, at least for me, from like the way I think of how things are built today. It's hard to imagine arriving at that conclusion. Like, this is the problem, and seeing this is like it's a lost art, I guess, really, right? Like to be able to think in these kind of ways, because we're so used to having fast microcontrollers and digital displays and stuff. You wouldn't be able to, or at least I certainly wouldn't be able to come up with this thing if I had infinite time and infinite monkeys behind me. I still wouldn't be able to come up with this design. The the mind that comes up with this is just a product of of that age. I feel so it was really cool to be able to use contemporary documents like they get the patents to bring it back to life in a way that just modern thinking would never go in this route.
Yeah, I'm not very mechanical myself, so I marvel at this kind of stuff. I've taken a lot of time working on teletype machines, and I've often said I'm convinced that, somebody in Skokie, Illinois was walking down the street one day and a teletype machine fell out of the sky, because I just can't believe anybody said, "Oh, you know what we could do?" I always thought the KSR 28 rollover mechanism for the keys was particularly brilliant. There was a tray of basically ball bearings. The top of the tray had holes, one for each key, and the key at the bottom had like a wedge. So when you pushed it, there were enough ball bearings in the box that they kind of moved around freely. But if you pushed down on the key, that wedge spread all the ball bearings out, and now the box was full of ball bearings, right? So if you tried to push another key down, it would not go down until the other key came up to let the ball bearings spread back out. And I'm like, really?
Yeah, right.
This was your first idea, really? Okay.
Well, complex mechanisms of a different sort for this one. This is print-in-place pump pushes limits of printing. I think it's interesting that 3D printers have hit sort of a quality level and affordability level that just printing something is no longer any great challenge or impressive feat, right? I mean, there was a time, and you'll know this, Al, there was a time where just getting something dimensionally accurate out of the machine was, a pretty good day. And now with these modern printers, I mean, they, that has been largely solved, and it's interesting to see now these more ambitious, I guess you'd say, designs that really are starting to push the technology forward, since we've arrived at a baseline kind of thing. And in this case, designed to wanted to produce a water pump that was entirely print in place with an impeller that would spin inside of a printed enclosure that's obviously also watertight, right? Because that wouldn't do you any good otherwise. And what I thought was really cool here is that just having an impeller that can spin inside of a printed enclosure is already a neat trick. But the way he pulled this off was by using water-soluble support material on a single extruder printer. It ends up only being 4 filament swaps, which I thought was really, really impressive, because I would assume it would have taken a lot more based on just the geometry involved, right? But you have a filament swap effectively like under the impeller. Also in there's pauses where he inserts real bearings on the impeller shaft, and the end result is it's not the greatest pump in the world. You could certainly buy a better pump, but that you could produce this thing. It would be easier if he had some multi-tool head or even a filament swapping printer, but he was doing this on what you consider like an entry-level machine, right? So to see this thing produced on that kind of a printer and to work pretty well. I mean, he pumps water, a few meters uphill at a decent rate, driving it with an electric drill. It excites me that this is the kind of stuff that you can pull off now on, like I said, effectively an entry level printer, for a couple $100 and quite a bit of ingenuity. You can produce complex mechanisms like this. And I've always been, a huge believer in desktop 3D printing and the ability to manufacture this kind of stuff at home. And it's very exciting for me to see, us enter this new phase of 3D printing where we're not just struggling to get out calibration cubes.
See, I'm sad about that, because I like to tinker with the machine. And so I've got a new machine, as you know, relatively new. And I'm like, oh, well, this is boring, because I push a button on it and it calibrates itself, and then it just turns out prints. And I take them off the bed and start another one. And it's like, oh, okay. It is nice, though. I do like designing my own stuff. And, I always say I couldn't be a writer without a word processor. I'm not that accurate, and I'm not a good speller, and there's a lot of other reasons for that. But I couldn't sit and, I guess Hemingway wrote on a legal pad or something. I couldn't do that. But it's the same thing here. I can visualize a lot of things in my brain that I have absolutely zero chance of building by hand, right? If you just said, here's some tools and some wood or metal, and, I can't do it. But I sure can draw it out on a CAD program and then watch it materialize over in my very slow speed Star Trek replicator over there, right? So I think that is impressive. One of the things that I think has been a real game changer for that, though, I mean, certainly, the slicers have gotten better. So supports and things like that, they separate better, rafts separate better. I think there's been a lot of that. I know he had some support material that was dissolvable,
Right.
but I think I showed you the video the other day where I had, because I've now got I've had multi-capability for a while, but I finally have it that works without me tinkering with it for 2 days before I want to print something. If you use PETG as a support for PLA, and I assume it would work just as well vice versa, that is amazing. Now, that probably wouldn't work here because his supports were probably like inside the body.
Right.
But man, just if you're listening and you print and you've got the ability to do that, try it. I promise you. Then you just go, oh, because it used to be I'd see something and say, that needs supports. I don't know. I don't really feel like messing with that, right? It's going to be, hacking it off with a diagonal cutters, and then, oh, wait, too much of it came off, So definitely, that's one of the things I think that is really going to be a big game changer. There's only so much stuff you can do with saying, oh, look, I printed something in 2 colors. I mean, you could already do that. Look at your badge for a Supercon, right? It had 3 colors on it. You don't have anything special. You just have to figure out where the colors go and do it a little better. But I'm telling you, it's a game changer if you have the multi material. It's just awesome. So I agree, though. I think it's a great thing to we're seeing the quality of even a cheap printer now is what you would have paid thousands and thousands of dollars to get even close to that quality before.
That was kind of what they promised, right, for 3D printing. That was the buzzword in the beginning, like, oh, you'll be able to just make anything you want, and to see that actually starting to happen because these machines are so much easier to use and because the software is getting more accessible is awesome. And makes me feel like there's hope for this yet.
Well, I'm on theme with 3D printing today, and I really like Don Papp's title for this, which was 3D printing liquid-filled filament was not on our bingo card. And I really like that sentiment because, there's all these things. Well, printers have 4 colors now. Well, you kind of knew that was coming, right? And one day the 8 will be normal, and then, one day they'll mix their own colors from pellet. Okay, you get that. But that was kind of surprising. And this comes from Prusa. You mentioned Prusa earlier. They have a new printer that is actually, it's a head for the XL that you mentioned, and it allows you to print in actual silicone. And I mean, there's people who've said, oh, you can print this silicone like plastic before, but this is really silicone. And it's actually 2 filaments coming in from a company called Filament 2. One of them is part A. It's like an epoxy. One's a part A, one's a part B. But the filaments have a liquid core. So when they go into the extruder, it actually cuts the sheath away and then mixes them in the nozzle, and then it comes out and it cures. I guess it cures pretty fast once it hits. I'm very curious, and I don't know the answer. I'm hoping somebody will hit us up in the comments that knows and tell us. But as Don says, quote, it isn't clear from the demo where the stripped outer casing goes, but we assume it must get discarded or is possibly stored temporarily until it can be removed. So I'd kind of like to know that too. Where's that going? I just thought that was really interesting. It's a material that, it's a very handy material. Obviously, I could see people printing like custom hot-end socks with this or something, right? Or anything you do with hot tools would be great with this. And what a cool idea to be able to mix 2 part of curable material inside the head like that. I was really impressed. So,
yeah, I mean, we talk about this sometimes where you don't know what you could do with something until you have it, right? So putting this kind of ability into the hands of, admittedly, the more affluent makers, right? Because the XL, is certainly not the entry level machine, but putting this kind of capability into the hands of everyday makers and stuff it's only going to unlock stuff that we can't really think about right now. You know, we can't. Obviously, there's like gaskets and that sort of thing that come to mind immediately, but there's going to be applications for this technology that are totally obscure to us yet because we haven't had it before. You know what I mean? Printing epoxy could be, and again, I don't know what you would do with printable epoxy, but someone does, right? And once we have that ability in the wild, I can't wait to see what people come up with it. So this is really cool. And when they announced the Prusa XL, like, okay, yeah, it's a big printer and it's got the print heads, and you know, like you were saying, color's never been exciting to me, frankly. I mean, that's what paint's for, right? But material is really the interesting thing. So okay, you got your main plastic, and now you got your support plastic, and well, now you got something totally off the wall, right? And that they kind of hinted when they announced the XL that there was going to be different tools down the line. It wasn't just going to be your regular filament extruder. So it's cool to see that start to actually happen. And of course, this is just the beginning of what you could potentially do. There was talk of, you know, laser heads and you know, CNC spindles and stuff, and we've kind of covered that in the past. I don't know that I'd like to see anything getting cut inside of my 3D printer enclosure or lasered for that matter because of the, you know, smoke and stuff. But finally seeing new and different heads for the XL that can do stuff that was impossible before this, right? To actually print in silicone is really exciting, and I can't wait to see not only what people do with this, but you know, where else does this go? You know, once you have this platform for swapping out heads that can do pretty much whatever you want, you know, and aren't limited to this traditional filament extrusion. You know, we're still a long way. You know, like you said, there's still at best a very, very slow Star Trek replicator, but this is the kind of stuff that you need to start doing stuff that's more complicated than you know, just little toys, right? You need to be able to start doing new materials and maybe even a little bit of subtractive manufacturing going on. So very exciting stuff. Don also talks about some of the other things that they were talking about. I think the open print tag is very interesting, where it's going to be an open standard for like NFC tags in the filament spools, which, you know, if it was anybody else but Prusa, I would be, you know what I mean? Like we've seen some of the other printers have this already, but they're kind of closed up systems, right? So the fact that this is being approached as an open platform where you can have the machine adjust parameters based on the roll of filament it sees is really cool. You know, I mean, ultimately, really, it just saves you from entering the info into the slicer manually, right? But I mean, it does kind of every change that makes the machine a little bit less obtuse, right, to use is going to be helpful down the line. And even stuff like you know, if you have the model sliced for PLA, and I've made this mistake, right? You know, you had a model slice for PLA and you put PETG or something on there.
I have done that.
It would be able to say like, no, like don't do that. Like you know, so that kind of stuff is really cool. And it just and kind of like I was saying before, like the machines have all kind of hit this level of like all the bases are covered, right? For just being able to put out reliable stuff. So now we're starting to see like this kind of quality of life come. That's going to take them from, as much as it might pain you, it's going to take them from these like tinkering boxes to tools that you can rely on. And
yeah, we saw that with automobiles, right?
Yeah,
in
sure.
1900, if you had a car, then that meant you were some mechanical nerd and you knew how to do everything you had to do to it. And now, you know, you go lay some money down, get a car. Most people don't even know how to change their oil, or half of them don't know how to change a tire anymore. And that's life, right?
Yeah. And it's interesting to think that 3D printers might finally get there, right? Because I that was the dream. That was what they promised everybody who would invest money when this was a when MakerBot first started putting these things out, and it was the buzzword of the day. Everybody knew was going to have a 3D printer, and you would just couple clicks and finished products would spit out of the machine next to you, and we know the reality is quite a bit different. But we're moving in the right direction, I think, with stuff like this. So it's really cool to see it happen.
Well, I've often said at the current level of tech, and I think it's already happened, but I've said this for, probably 15 years, 3D printers will be as common as drill presses, right? You don't meet somebody and they say, I have a drill press, and you go, what? Really? A drill press?
Yeah.
But not everybody has a drill press, but it doesn't even remotely surprise you if somebody has a drill press or a table saw, or, right. It's that level of thing. If you're a tool guy, that's going to be one of the tools, that you have. And if you're not a tool guy, you're probably not going to have it.
Yeah, absolutely. And much like a table saw, you can't just throw a block of wood on it and have a chair come out the other side, right? Like there's still skill involved, but it makes it's a force multiplier, right? It makes things far easier as long as you know how to use it and to get the most out of it.
Without the laser cutter, all my woodworking projects are toothpicks. They don't start out as toothpicks. That's just what I want. I'm like, okay, I made more toothpicks. There you go.
Well, my first quick hack this week is CardFlix, NFC cards for kid-friendly streaming magic. This is a project we've seen done in different ways many times over the years, but I never get tired of it. I think it's really cool. Where effectively, putting NFC tags on little printed cards that have, Toy Story and Bluey and whatever the youth enjoys these days on them. And your kid can tap that on a little NFC reader and hooks up to your home automation system and gets the appropriate videos playing on the TV. Obviously, it's not just for kids. I mean, there's a lot of potential here for like assistive tech and people with limited mobility. They could put up their favorite movie or music, or just convenience of it that you can just tap a little card on a reader and cue something up. And I always like to see these different variations on that theme. Next up is Print and Clamp rubber band PCB stand slides into duty. This is a really cool. I don't even know how to describe it. It's not like the PCB clamp I have on my desk for sure. This is a disc with kind of a Y shape cut into it and little rollers, a rubber band around them, so they all want to meet in the middle, right? And so you can pull them apart and put a weird shaped board in there, and they kind of conform to, within reason, the shape of your PCB. I've had printed PCB holders before, and they are very handy, especially for being effectively free, right, for the cost of some filament and a rubber band. Obviously, you gotta be a little bit careful not to cook them inadvertently while you're soldering, but hey, if you melt it, the next one is just a few clicks away. And finally, this is a proper hack. This is SolidWorks certification with FreeCAD, and this is when you have maybe more time on your hands than you know what to do with. Delta Hedra decided to go through the SolidWorks professional exam with FreeCAD, and got there in the end. It took maybe a little bit longer than you were supposed to, because it's FreeCAD, frankly, and it does take a little bit of a certain mindset to get the most out of it, but was able to accomplish all the goals and challenges and what have yous in the certified exam. And I think it's an awesome demonstration that it's not the tool so much as the person using it in terms of what kind of results you can get.
Well, my quick hacks this week. Bachicha has the multitasking on the humble Z80 CPU. And, of course, I've seen, like, the YouTube video has the title, Can the Z80 Multitask? And I'm thinking, well, yeah. We've done that forever, but surprisingly, a lot of the comments on the video and the comments on Hackaday were like, no, it can't multitask because it doesn't have all this modern equipment. It's like, well, it's not really necessary. You can do it. It just, there's limitations, obviously. The next one was a very controversial hack from CypherTech, and it's a simple device can freeze Wi-Fi camera feed. So, from a privacy standpoint, you go to the Airbnb, you don't really necessarily want the hosts, streaming you out on some nefarious channel. I don't know which. I can't think of one. But so with this device, you jam the Wi-Fi feeds from cameras called the RF Clown. I don't know where that name comes from. But, the problem is, of course, that's probably highly illegal to just maliciously interfere with Wi-Fi signals. So my guess is you might get a knock on the door if you actually built one of these. But I do think there's some interesting thought there of saying, well, I don't want people filming this, so therefore I'm going to generate something to interfere with it. And then the interestingly named Scart Vader, I think that's how you say that. He had another component abuse challenge that I wanted to point out, which was using an input as an output. And it's actually pretty clever, and it has to do with the internal pull-up resistors on the input, and that you can switch them on and off, and then detecting that from outside. So, but anyway, so for the component abuse challenge, I thought that was certainly an abuse of a microprocessor. Well, you want to talk Supercon 9?
Yeah, I thought for this episode we might break tradition a little bit, and instead of talking about the can't miss articles, talk about the can't miss event of the previous week, which was absolutely Supercon. It was great. I mean, episode over, right? It was great. I don't think we ever had a bad Supercon, frankly. And I think, we talked about this a little bit while we're out there. I think part of it is just such a great community that once you get so many of these people in one place, and you kept them fed, and it can only be good, right? Like, you have so many like-minded people who are there to share information and show what they're working on, and are they have come from, if not across the globe, at least across the country, just to learn and discuss. And everybody's just so happy to be there, and so positive, and so willing to share, and there's no competition of egos. It's not like, oh, well, I've been doing this for everybody's just on the same page, and it's awesome. It's frankly, it's the highlight of my year is going and just seeing all these people and talking with them, and see what they're working on. And I always come away not only just impressed with the crazy stuff this community gets into, but I learn something every year. And it's the kind of thing where I think unless you come, it's hard to really explain, right? I mean, we could say, yeah, it's talks, and it's badge hacking, and it's camaraderie or whatever, but it is very unique, even within hacker cons. And I've, part of the gig of working for Hackaday is I've gone to several hacker cons, right? And write them up and that kind of thing. And even among other similar events, I think we have cultivated a very unique feel, and a large part of that is just due to just how great this community is, right? I mean, we do what we can, but they bring the real substance to it. We set up the framework by organizing Supercon, but they bring they bring that last element.
They bring their enthusiasm, their projects, parts to share. I mean, that's what always amazes me, is how much people say, "Hey, does anybody have a 1N914 diode?" And 10 people go, "Yeah, here, I've got one in my pocket." It's really interesting. I can't agree with you more, though. It's one of those things. It's like going to Woodstock or Burning Man or something. It's like you could describe it all day, but it's not the same as when you're there. It's like, oh yeah, that's really different. I think part of it is the people are very, unlike a lot of times in the real world, good to each other. You don't really see people getting into shouting matches
No.
or shoving each other or being rude to one another. And honestly, people leave probably $15,000-$20,000 worth of materials just laying around on the floor under tables and stuff. And as far as I know, no one ever loses a thing, right? Because everybody's just not in that mode.
Yeah.
I mean, it's like it's one group of people. It's like a family or an organization, and nobody feels like an outsider. And I think that's really cool.
Yeah, I almost hate to say it because now we'll jinx ourselves, right? But like, you had pointed out too during it, this was Supercon 9, and there's never a problem, right? There's never a fight that needs to be broken up. There's never a raised voice. There's never, hey, somebody took something off my table. I mean, it's just, and it's to get together, 500 plus strangers, right? Ultimately, and to not have any kind of altercation or problem over 9 years is incredible, right? And I don't know how many other, how many events can really boast of that. And I think it is just kind of a testament to how everybody really is on the same page. Like, nobody's coming here to start a fight or to cause trouble. Everybody just wants to have a good time and enjoy this. It seems like 3 days is a long time until you're there, right? And then it's over in the blink of an eye. So there's no time for being petty or causing issues. Like, let's all be on the same page and have a good time and make the most of it.
Well, next year we'll stage a West Side Story style dance fight for you, Tom. How's that? So there's two things I definitely want to talk about before we get off of this topic, though, is, first of all, the keynote was pretty amazing. I know you're going to have some opinions about that. And I would like to talk a little bit about the badge hacking. Why don't we talk about the keynote? How did you like the keynote? And just in case people who weren't there aren't following what we're talking about. So the keynote was this amazing presentation with several illustrious guests, all of whom had a hand behind the scenes on either a Star Trek movie or a TV show. And so they were the artist and the people who made if you saw a Klingon with a pistol, they had made the pistol. And there were a couple of different functions of people there. And of course, the Akutas were there, who they've had their hands in all sorts of design parts of Star Trek. So, they were kind of the makers or the hackers of Star Trek behind the scenes.
If you saw these people at like a Star Trek convention, the kind of the questions would have been more tricky, right?
I think that's what made that so interesting is, you go to a regular Star Trek convention and, here's this actor who played Bob on episode 97. And you go, oh, hey, Bob, what was William Shatner like or whatever, But this was a little different because this was like, oh, if you have to produce a gun to be seen on TV for 8 seconds, what's the quickest way to do that without, breaking the bank, but it still looks good.
But we had, through the badge, which we can get to in a minute, we were doing question and answer kind of thing, and attendees could send their questions up, and I was watching them as they went through, and there was none of that. Like, their questions, like, for this audience, the Supercon audience, was not, what was your favorite actor, or what storyline did you like the best? It was like, what workflow do you prefer for, creating resin props, and like, what's your favorite software for doing sketches? Like, it was very nuts and bolts. And I really think that they appreciated that, frankly.
The interior designer, I can't remember her name now, but, she had said she works on a lot of different TV shows, but that, if you're working on something like Star Trek, there's no Home Depot for outer space in the future. You can't go to the furniture store and just say, let's pick that sofa and that, So it was very interesting to hear their take on that. And there were just so many years of experience of people creating interesting, futuristic looking things. Maybe they weren't really futuristic, but they looked futuristic. And, all seriousness, Star Trek had, predicted a lot of our future, right? I mean, we were joking about the 3D printers being replicators. They kind of are in a weird sort of way. cell phones and communicators, et cetera. But I do think one of the cool things was, even if you weren't a Star Trek fan, it was really interesting to hear about these people's jobs, because if you've ever wondered what it took to do behind the scenes on a production like that, even if you don't care about Star Trek, that's still pretty interesting. And they really had a great presentation. So
several of the panelists stayed. I mean, obviously they were welcome. We made that clear. Like, you're welcome to stay as long as you want. Please, please talk to us about Star Trek and prop making as long as you like. But they stayed for hours, and some even came back the next day. Right.
Well, I was going to say Bear came back the next day. Right. So
yeah, Bear came back the next day. I think they really resonated with that. Because they're creatives too.
Well, and I can imagine too, it must be a nice change. Because think about it, if every time somebody saw you, they said, "So what's Elliot Williams really like?" You're going to go, "Oh, I'm tired of that." Right? Sorry, Elliot, if you're listening, but you kind of want to have your stuff looked at, right? So I think they probably really enjoyed that they got to tell their stories, and one of them had a really funny story about having put a gun maker's logo or on a fake gun that wasn't visible until it was, and then he got in big trouble for it and all that. So, there was just a lot of little anecdotes that was very, very entertaining, and something I think we can all relate to. I mean, even if you're doing software, how many times have you written some comment that probably if anybody saw, and maybe even somebody saw, and then you got in trouble for it? I think we've all got one of those stories, right? So it's very, very kindred spirits there.
What did you think about the badge?
The badge was awesome. Space Ben did a great job. Everybody else on our team that worked on it did a great job. If you didn't know, the badge was like a little, it almost looked like to me like one of those old Casio basic calculators, or like an HP LX85, or, it was a little handheld device with a keyboard, but it also had a radio. And they could talk to each other, and it formed a mesh network across the venue, probably beyond, honestly. So it worked really well. We had different channels. I was disappointed, I will say, they had already finalized it. As you said, they asked for questions on the badge. So as the speakers were speaking, people were typing their questions in on the Star Trek stuff, and they had given them a particular channel to go to, and I had said, "Oh, you should have used channel 1701," and they were like, "Oh, we already did the slides." I'm thinking, dude, PowerPoint, change the slide. But I guess that was maybe they'd already sent them to somebody or something. I don't know, but I was like, man, 1701 would have been the channel for Star Trek questions, right? So yeah, it was really well done. There's some software issues. I know Ben was real excited when we did the vector scope. He really enjoyed the operating system for it. So now he's written his own operating system in MicroPython, and I think he has even more respect. Because it's painful, dude. It's a hard thing to do, and I think he would not disagree with me on that point. So, but it worked really well. It was super great how easy, there were little example places to put your code, and it was super easy to integrate code into it. And his method of doing that wasn't maybe as flexible as some other ways you could have done it, but it was super, super easy, and it worked well with the restraints you have with MicroPython. So I thought it was very clever the way he did that.
Well, I think, the Hackaday Supercon badge, right, is sort of is a key component to the Supercon experience. And, while their events can just give you, for lack of a better word, a finished device, you go to another event, they give you a badge, and you just wear it around your neck, and that's kind of it. But like, our expectation is for you to dig into it and break it and rebuild it, and kind of, it is part of the experience, right? To the point that on Sunday we have the badge hacking competition. So we wanted to give the attendees a badge that worked, but almost didn't work too well, if that makes sense. We wanted there to be room for improvement and areas where you could fill in some of the blanks. And to that end, I think it really worked, because we saw, Ben was kind of keeping an eye on the GitHub repository for the firmware all weekend, and I haven't checked since, but I know when things wrapped Sunday night, there was over 40 pull requests that had been closed, and they ranged from everything from, hey, you guys could speed this up, to here's a vastly improved version of some onboard software, or here's something totally different, right? Like a new programs and apps that we hadn't even considered. So it was extremely successful in that regard, and like you said, I think we have to got to give Ben a lot of credit for that, because he did come up with just a really user friendly way of adding your software into this device, and the result is unquestionably that the firmware on Sunday night was more refined than it was on Friday morning, and it was really cool to see that happen. If there was maybe a downside to the badge this year, I think it's that it was not as inviting for hardware hacks. Several people had said it felt like a finished product, which is a first for us. We usually have, a PCB that's just kind of hanging around your neck, to the point that I had a couple people say to me that, this was the first badge we had that had like a full enclosure. It was all wrapped up, and some people said they actually felt like they weren't supposed to open it. Like they felt like, okay, well, it has an enclosure, I'm not supposed to open it, which is,
that's not true. This community, I'm not buying that. I'm sorry.
You're right. Like that is definitely not our intent. Our intent was certainly not for you to not open it. It's just, we had the LiPo pouch in there that needed a certain level of protection, and the ribbon cable for the screen was really fragile. So we didn't think we could get away with the traditional, hanging PCB. But
I do think if we did it again, though, we should have bundled a little screwdriver.
Well, somebody even said that, like there were no screwdrivers. We didn't think, there was no screwdrivers on the tables or anything. So they're like looking around, like, well, there's no screwdrivers, and they didn't give me one. Maybe I'm not supposed to open it, but I think we got to put a sticker on the back that says like, "Please open me," for Hackaday Europe or something. Yeah. But
no, I think you put a sticker on the back that says "No user serviceable parts inside." That always makes me open something. So.
But then also, we the design was using up pretty much all the pins on the ESP32, so that we didn't have like the expansion port of previous years. But it's fine, right? It ended up being more software hacks than hardware, which is kind of an interesting change of pace for us. But it was still an incredible amount of attendee interaction with the badge, and I don't think anybody was disappointed. It was just an interesting change of pace, I guess, for us. That it was more software than hardware, but it was very much like everywhere you looked, somebody had a badge hooked up to their computer and was working on it and tinkering with it, and that's all ultimately what we're shooting for. So it was definitely successful in that regard.
I wanted to spend more time on the dad joke channel, but I was too busy.
So that was really cool. It is a LoRa radio. For various reasons, we didn't go with Meshtastic out of the box, although the intent is absolutely for it to be Meshtastic compatible, and we're working with the Meshtastic folks to make that happen. But we ended up doing our own LoRa Meshtastic Lite, for a lack of a better word, during the con, and part of that was that you could kind of punch in an arbitrary channel, and two or more badges that were on that channel could chat with each other, and we had this kind of notion that a few people would be talking and saying, "Hey, let's continue this talk on channel blah 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 blah," and they could just type it out. So one of the things that was really cool was that there was this emergent content where certain channels got taken over. Like Al was saying, one of the channel 42 was just dad jokes getting spit out, and there was chat bots running on other channels, and it was really cool to see that stuff just happen in real time there was no plan, or limits. We just said, hey, here's 50 odd channels across, so many frequencies, and just do what you want. And it was really, it was fascinating to see the sort of stuff that just appeared out of thin air.
Yeah. Like I say, I didn't get as much time to look at that. I tried to organize some hams on channel 73 for a while, and there was a little bit of that, but mostly just, hey. So wasn't a whole lot going on there. I stay busy during the whole conference because, of course, I usually host the SMD soldering challenge. And I don't know, I know you saw part of this. It was really fun this year. We had some really tough competitors, but at the end, we typically run 8 sessions of that, and then we bring the 8 winners of that back to a final. And there's usually some little twist on the final. So this year, unbeknownst to anybody except a few of us, they had given us boards that had, normally they go down to what, 0204 or something like that. And those are really small, but this board had two 01005 LEDs and resistors on it. So, 4 components that size. I looked it up. That's a third of the size of an eye of a needle. So 3 of these would fit into the eye of a needle, basically. They're almost impossible. I mean, the other ones are hard to do, and these are super hard. So I played a dirty trick on the guys. I told them, don't turn the boards over until I tell you, and I've dealt them face down like cards. And then I said, okay, when I tell you to, turn them over and let me know if you see anything different about these boards than the ones you did earlier. And as I said on the stage there when we were handing out the Edge Awards, they turned them over, and then I learned a few new curse words. Right? They were very excited to see those small parts. So the rules I put into place were, if you were sure you could do it, if you could solder down, and get it working, one of those little bitty LEDs, the fastest person to do that wins. But if you thought nobody could do it, you could do the other ones fast, and the fastest time there wins. But if anybody gets, even in the whole amount of time, gets the little one, they would take the prizes. We actually had somebody put down a perfectly functional 01005 LED that blinked appropriately in like 9 minutes and I think 50 seconds. Anyway, under 10 minutes. It was somewhere between 9 and 10 minutes. So that's pretty amazing. Somebody else elected to do the other route. But then after they took their time for that, I think it was Pepper, went ahead and soldered down that part also and got it working. But of course, by that point, I didn't allow that for credit. So the good news was, because of our generous sponsors, everybody who was in the finals went home with cool prizes. There was several iFixit. Some of those were provided by DigiKey, some by iFixit. There was a soldering iron, some toolkits. There was a limited edition Arduino Uno that was signed by, all the Arduino luminaries and numbered. We had last year's badge was one of the prizes. That was actually the first place winner, took last year's badge home. And a couple of things from a couple of display screens from Pimeroni people. So it was really, really great for the sponsors to give us enough swag that everybody got to go home with something that placed in the finals. So thanks to them.
Well, I still think for next year we got to have a shirt that says I survived 01005.
I think next year we're going to have some fake boards made up that have nothing but 01005 on it and just say, here's the board. And then go, no, just kidding. Give you
That's all for this episode of the Hackaday podcast. Head over to hackaday.com/podcast to see the notes for this or any of our previous episodes. And remember, if you see anything cool or do anything cool, email us at tips@hackaday.com. Thanks for listening, and until next time,
keep those hacks coming.
Yeah. Okay.
Yeah, I understand. So you want to try again?
Cheap stuff running Linux good.
Is that your SCART Vader sound effect there, Tom? On 3, turn your boards over and let me know if you see anything. You hear that, by the way?
I did. I thought that was memory kicking in. It was going to be a flashback.
Yeah, exactly.